Hello everybody, this is Della from The Beauty of Play. Today I'm going to go over some books and resources that I'm using for our G8 geometry block, and also I'm going to give you suggestions and books that you might use that we're not using. I'm going to start with Making Math Meaningful. This is one of the most important source books that I use. It's my main source book, and it has 8th grade geometry in the middle of the book. This book is a wonderful source book. It has a plethora of information packed into the little book. It talks about what it is, and it has some thoughts on teaching and prior information, and also practical advice on teaching algebra and so forth. This one is for middle school. There's also one for elementary school and one for high school. But I will say, unless you were a math major, the high school one is a little challenging. I love it, but I've had to take teacher courses to understand. So it also goes over the main topics for math curricula in the Waldorf pedagogy, and it gives an overview at the beginning of each section. So for 8th grade, it has a basic overview of what is being covered in 8th grade, and then it goes through by blocks and gives you basic information about those blocks. Okay, so 8th grade geometry is set up in this way. It is not a curricula, so it's not open and go. It's not going to tell you how to teach. It's going to give you the information that generally is covered, and then also the information about the concept if it's not a really common one and might not be well known. So it goes over this picture proof that we did lately in our geometry of cutting up a circle into pie pieces and making it into a rectangle, and it also does the Archimedes version of the area of the circle that you also saw if you were on social media in our main lesson books. So it goes over quite a bit. In this block, there's also finding volume of solids and looking at the relationship of volumes of solids one to another. For instance, it looks at the relationship of pyramids in a cube. It also looks at the relationship of the cone, the sphere, and the cylinder with the same circumference. It goes over a little bit about surface area, but not too much because that is not the main focus. And then eventually it goes into Platonic solids and stereometry, which is the main focus of G8 geometry. This is like the highlight. Each of the years has a highlight from 5th grade all the way to 8th grade, and Platonic solids is definitely the highlight for this. This is where I got the transformations that we're doing with clay. We are not doing the dodecahedron to the icosahedron. It was hard enough to do this one. We did talk about what duals are and how to get there. And it gives over the duality of the duals and how the midpoints of one solid are the vertices of another solid, and nets and so forth. So this is the main book that I'm using for my planning of this unit. In addition to that, I have used Drawing Geometric Solids, and this has a lot of different solids to use. We will be doing more of these where it's talking about the duals and drawing the duals. And it also goes into the more complex shapes. And it even goes into stellated shapes, which I'm not sure we're going to have time for. I would love to go into that. Like all of math, there's just an infinite amount of material, and you really have to pick and choose which one you do. We can't do them all. So there is this one. And then another one that we use is First Steps in Proven Geometry for upper elementary grades. This goes into the middle grades too. It talks about upper elementary, but you know, depending on where you are, what country and so forth, those are a little different. So we would be roughly at the back here, and this is talking about, I think, projective geometry, which we are not doing, but is in the book, Jamie York's book here. But it does talk about the nets and the solids, which we are going over, but this also goes over all of the lower level geometry that we are reviewing, with formations of a circle, triangle, and special triangles, and polygons, and proofs, and so forth are from this book. We have been using a series of books are Folding the Circle. These are from Whole Movement, and you can find those at wholemovement.com. It's work from Bradford Hanson Smith. This is really interesting. He's an amazing artist. I highly suggest that you go check him out. This has been a wonderful experience with geometry. Very different, very experiential, and it has been really great. We started with folding the circle in half and a half again and making observations with quadrilateral, and then we moved into folding it in half and into thirds, which gives us 6 diameters, bisecting the circle, and we observed that, and then we moved into more diameters. But then we went into the work with the vector equilibrium, which was really interesting, and making our sphere and then making a tetrahedron from those spheres. And we talked about spatial arrangement and packing and the shapes inside the shapes. And then we moved into folding into a equilateral triangle, which was very interesting, and we were able to make a lot of observations from that one triangle, and that led us into the net of a tetrahedron. That was our first shape that we've done so far with this, and there's lots of notice and wonder with this, which I find to be just so hand in hand with a Waldorf education, is the experiencing, learning, and discovering information. It also is very in line with Charlotte Mason. So we are making observations with this. We are writing down our observations. Our equilateral triangle also brought us straight into our work with special triangles and angles. It was reviewed from last year and the year before, and then finally we made our tetrahedrons. We made loads of tetrahedrons. We talked about 2 frequency, 3 frequency, and 4 frequency tetrahedrons, and then we also made Sierpinski's triangle using these tetrahedrons. And we even made observations about different ways that you could connect them. It has been a really interesting journey, and I am looking forward to going further into it. It goes into the octahedron, and it's a little different than Waldorf travels through, and I am just going on the journey with her and seeing where this leads. You can see here that it goes from the octahedron to the icosahedron, and we are going more on the number of faces than the shapes. And then into stellated, and then finally it comes back to the observation of the properties of the 5 Platonic solids, which we have already done that aspect. It spends a lot more work on the tetrahedron, and I went ahead and got the second book because I want to make sure that we also get the dodecahedron. There's some really elaborate stuff that we won't be going over. Look at these curves that it can make. It's absolutely beautiful. This eventually moves in to the pentagon. Here we go. And I wanted to definitely include the pentagon and the dodecahedron in this. Most of the shapes that even the cube that they are making are coming out of the 6-fold, the 2 and then the 3, which gives us a hexagon, and then they're eliminating one of those by folding a corner in to give 4 and 5. You can also do it, if you look over here, it talks about the ratios and getting folds for 1, 3, 4, and 5, which is essentially doubled. They're counting the diameters, but this is folded in half, and then this gives us 6 sections, 8 sections, and 10 sections. But you could obtain the square from the 4 and the pentagon from the 5, but they're mostly using the division of 6, which is one of the easiest divisions in my opinion for a circle, to obtain the 4-fold symmetry and the 5-fold symmetry by taking out triangles, squeezing those together to obtain it. And you can see that here in how they're doing the folds for the pentagon. And you can also see that the shape is slightly different than the flat surfaces that we see in the tetrahedron, octahedron, icosahedron. And then they also go into more complex. There are several books. I just have 2 of them. I think there are at least 3, but this is really all we need for now. And this is new to us, and for me, one of the more exciting aspects of our geometry. Another book that we are not using, but you might find interesting, is The Power of Limits. And this book looks absolutely fascinating to me. Here you see the logarithmic spirals, which correspond to Fibonacci's sequence, and I would love to do this book. It relates a lot to what you see in nature, which is something that I really love about Waldorf geometry, but it is beyond what we can do at this time. Just is not enough time, but I do find it absolutely fascinating. These books are the Woden books, and I call them Woden. They may be pronounced wooden. They're spelled like wooden. We have several of these. They have a whole series. I think some of them are shown here, the Woden books. We have several. I know there are more because we have them. These also are packed full of wonderful information that show the geometry and the patterns to the geometry. They often show the patterns to nature. It's just really interesting books. I love these books. They go over different tiling and geometric tiling and Islamic tiling. Geometry is very much in Islamic tiling. And this one is specific to plate tectonics and Archimedes solids. And we will likely be using this mostly. I don't think I'm going to use the other for this particular block. It goes through the plate tectonic solids and the shapes, and then it talks about their relationships. It also has a short proof of why there are really only 5 polygons. So if we look at the triangular, the different faces, shapes that we can have, for the triangle, we can have the tetrahedron that uses 3 equilateral triangles, or the octahedron that uses 4 for the top and 4 for the bottom. This is a portion of an octahedron. Or we can use 5, which gives us a pentagonal shape. This gives us the icosahedron when we use this pattern. And then if we use 6, it lays flat. There's no more solids that can be made because this tile's flat. The same is true for the cubes. Only 3 cubes actually tile into a solid, and then when we add the 4th square, it is flat, and the same for the pentagon. We can get 3 shapes that gives us the dodecahedron unit, and if we do more than that, this is actually hexagon, and with the hexagons, they again tile flat. So this is like a picture proof that there only exists 5 Platonic solids. And then these are the duals of the solids, which is really interesting. They're showing the tetrahedron inside an inverted tetrahedron inside a tetrahedron. And this one, they're showing the octahedron inside a cube and the cube inside the octahedron and so forth. So these are talking about the duals. And then it goes into a lot more complex stuff that we're likely not going to be doing, like the relationship with the golden ratio and stellated shapes, and then the Archimedes solids, which also have the truncated shapes in them. So it's just, this is a really interesting book. I always find these fascinating. Another book that we use for support is Drawing Geometry. And in this book, it just has instructions for geometric constructions. So how to construct the equilateral triangle. Usually these are inscribed in circles or using circles for the construction. This one actually is not. This is starting with a line and drawing a pentagon from that line. They're using the arches of the circles to find those. But this is useful if I have forgotten how to construct a given polygon. I can just grab this and it gives me instructions for how to do it. At this point, I don't forget that very often, but it also has some really interesting higher level constructions. Like these are inverted squares. These are inverted pentagons, like nesting pentagons, one inside the other. And this is a progression of polygons, which this is one of my favorite constructions. I really like this drawing. We used this on a chalkboard drawing for number bases, if you remember correctly. Another book that we are using is A Beginner's Guide to Constructing the Universe. This has workbooks, I just found out, that go along with them. They might be hard to find. I don't think they're widely printed, but that would be really interesting. This book is set up like the study of numbers, which Waldorf Geometry very much does. It takes grade 1 and moves the study of numbers into geometry for 5th, 6th, 7th, and 8th grade. And so it starts with the circle, which is the monad, and then it goes into 2 overlapping circles, which is the dyad, and then it works through the triad, the triangle, tetrad, 4, square, pentagon, and so forth. It goes through the numbers. It has a lot of information of where we find these things in nature, which I always really enjoy. Like these are star trails. If you do photography and leave your shutter open, you can capture the star trails. It doesn't actually take very long, like half an hour, to get a good series of star trails. I know this from my son's photography. Anyway, these are concentric circles, and it talks about other places that we see circles, and then it moves into the dyad, which is 2 overlapping circles here, which gives us 2 points that forms the line. It talks about polarity, yin and yang, day and night, dark and light, different electron charges, north and south in the poles, and also where we see these shapes in cell division, in stomata. This is this almond shape from two overlapping circles. We see it a lot in construction. It's really interesting. I love this relationship here. This is a series of roots, right? The square root of 2, square root of 3, square root of 4. In the cube, the diagonal for the square is the square root of 2. When we have an equilateral triangle, the bisector of that triangle is the square root of 3. And when we double this square to a rectangle, its diagonal is the square root of 5. And then it goes on to show the different relationships for the multiples. For the triangle for 3 is 3, 6, 9. 3 and 6 are triangular numbers, and 9 is a square number. For 4 and 8, 4 is a square number. And then if you were to keep going, like 16 is also a square number. 8 is an array, but in multiplication, all of our products are arrays, so this is not particularly special. And then 5 is a pentagonal number, and 10 is another triangular number. So it's just interesting, the series there. And then we move into the triad, which is the triangle. And it talks about the strength of the triangle in arches and in architecture, and where we see the triangle in various fruits and flowers. And it's really a great book to bring into the nature aspect and pulling from science and nature into mathematics, where we actually see these 3 triads. And this is the pigment for color and the light, the 3 primary colors for light. Then it goes and moves into the tetrad, which is the square in a polygon, but this is the first time that we can move into a solid with the tetrahedron. 4 spaces on the tetrahedron give us our first solid, and then we see the tetrahedron everywhere in nature, particularly in chemical compounds like methane, ethane, ammonia. And so this is really interesting and very relevant, seeing that we just got finished with chemistry. So we have just hit the tetrahedron in our studies, and I'm looking forward to bringing this back into a past block, because I feel like that, one, gives us a review and memory recall, so enhances learning, and then also making those connections to each other also helps our learning. The more connections we have, the greater the learning. And then this goes on through 5, 6, 7. This is really interesting too. These 5 Platonic solids were corresponding to the Greek elements fire, air, water, and earth. And then the dodecahedron was heaven above. And what is really interesting about this is one of the astronomers, before Copernicus, when they were trying to figure out the orbits of the sun, the moon, and the planets, they really thought that they corresponded with these Platonic solids, which is really interesting. And over here, we see the drawing of the joules, the transformation of the joules. Each of the solids has its own joule. If we take a look at this, the tetrahedron is its own joule, and you'll see the symmetry in the faces, the edges, and the corners. Both the faces and the corners, or the vertices, are 4 for the tetrahedron. But when you look at the other joules, like let's look at the cube, which is a hectahedron, and the octahedron, these 2 are joules. You will see that the number of faces and the number of corners are reversed. And this really makes sense when you look at this and see that when an octahedron is encompassed in a cube, the vertices of the octahedron hit the midpoint of the face. And you can see if we start to squish the corners of this cube into the center, then it progresses, and finally we have a tetrahedron. This is what we did yesterday for our work with clay. The icosahedron and dodecahedron are also duals. We did not do that with clay. That would be far too much for us to do. And then this goes on to the pentagon and the hexagon and so forth. All of them showing where we find them. Echinoderms have 5-point symmetry, which is really interesting. Some of the fruits, when you slice them open, have 5-point symmetry, which is really interesting. And the human bodies, the ratio to the human body is in the golden ratio phi, which is the ratio of an inscribed pentagram in a pentagon, and the golden ratio, which is really interesting. We see that in Fibonacci sequence and loads of other places in nature. Math really is the language of the universe. So this also goes into the hexagon, the heptagon, the nonagon, octagon, and so forth throughout this book. This is really useful for bringing the practical things that we see in nature to our mathematical understanding, making those connections. Okay, moving on into read alouds that go well with this. This is String, Straight Edge, and Shadow. We have already read this book, so this is not one that we're reading now. I see a lot of people read this in 5th grade or even 6th grade, which is, it's very layered, so it's not like I don't think that you can get anything out of it. It's worth reading. But it has some higher level geometric concepts in it that I think are better for 8th, 9th, and maybe even like high school geometry. However, we did read it, I think, both in 6th grade and read it again in 7th grade. It is a history of geometry, so it is about the Ionians and the Greeks, Egyptians, and that whole area of the world by the Mediterranean Sea. And it does a great job both storytelling and then also giving geometric concepts. Like this is the concept of the right triangle in the 3, 4, 5 that the Egyptians used in assessing a piece of property for taxes. So that is just a really interesting. It also goes into proofs of Thales and his being able to tell the height of the Great Pyramids through similar triangles and his shadow. So it's a great introduction to a lot of geometric concepts. Thales' proof of this being a right angle when you have a triangle inscribed in a circle with the base as the diameter. So just a really interesting book. We have already read this, so we're not reading this for this block. We are reading a series from Joy Hakim, The Story of Science. She has 3 books. The first one is Aristotle Leads the Way. We just finished this one. We've been reading through it throughout the year. It also is a history of the science. It covers chemistry, astronomy, physics, and mathematics. Ironically, it does not cover the biological sciences at all. Now, you know I'm partial to the biological sciences as a marine biologist, so a little disappointed in that, but we have supplemented with other material that goes over the history of the biological sciences. I do love Joy Hakim's this series, her books. They are fabulous. She's a wonderful storyteller, and they are chocked full of information. It is told in an interesting way, so it goes over and reviews much of what we're going over in our geometry and our sciences. Like with our chemistry, it is not synchronous to what we're doing, but I find asynchronicity to be a real positive in teaching because it gives us the opportunity for memory recall and for review of past material. So I really enjoy that. And it is like I said, interesting. More than one occasion, my daughters come to me and said, they talked about X, Y, and Z in the book today, just like we did, you know, whatever. Or she was talking about Heron's formula for finding the sides of the triangle. And she's like, they have this formula, like the Pythagorean, but you don't even need the Pythagorean theorem. It doesn't have to be a right triangle. You can just find all the sides by using this formula. So I'm happy that she's interested in that. So this one is Aristotle Leads the Way. It goes over much of the Greek, similar to this. It's a little more modern day storytelling, and so it's a little bit different style than this one, but they're both narrative. And then the second is in that series is Newton at the Center, and this goes over Kepler and Galileo and Newton and Copernicus. So this is really interesting part of that history. So we have just started on that here. That's what these tabs are, and we will work through this book. And here is the table of contents for this one. She has these little symbols that go over whether it's talking about science, math, technology, geography, religion or philosophy, art or music. This one right here, gravity, how observed, calculus, who's done it. So if you go to 154, these are little inserts, and that's what those symbols are for, these little inserts telling you what they are talking about. And the last in that series is Einstein Adds a New Dimension, and this is more modern history of the sciences that we will get into later, maybe next year. That is all for me today. Thank you for watching. Hope these were useful in your coming up with your own block. If you enjoyed the video, hit like, subscribe if you'd like to see more, and until next time, happy homeschooling.